Hey, what's up? Welcome back. Patrick here from All Things Mathematics, and moving on to the next example on the test, another thinking question. This one's going to be fairly challenging, so we have to find the equation of the tangent, or tangents, there might be multiple ones, on the function f of x equals negative 5x squared minus 1 that also passes through this point, negative 0.5 and 9. So I've gone through examples like this in the lecture videos, also on other tests on the website. I suggest getting as much practice as possible with these kinds of questions. They are fairly popular, not saying that it will come up on your particular test, but I have seen it come up quite a bit, and they're fairly challenging questions. So I'm going to first explain what's going on visually before we get into the actual algebra. So if I take this function, right, negative 5x squared minus 1, and if I graph it, so it's basically a quadratic that got flipped over because of the negative 5, and then it got shifted 1 down. So it looks approximately like this, right? Now, what makes this question difficult is that this point, negative 0.5 and 9, which is like, let's say up here, okay, this point is not on the function. So you got to be careful. Maybe if you read this, you might think that this point is on the function, because there are much easier questions where they give you a function, they give you a point, and they ask you to find the equation of the tangent at that point, right? But those kinds of questions are infinitely easier than this one here, where the point that you're given, this negative 0.5 and 9, is not on the function, right? If you plugged in negative 0.5 here for x, you would definitely not get 9. You'd get some kind of negative y value, and you could see from the diagram here. And so what we have to do is we need to find the equation of a tangent that's tangent to this function. So it's going to be a line that's tangent to the function, but also goes through that point. Let's maybe make the point a little bigger, like that. Right? So it has to be tangent on this function, and it also has to go through this point, negative 0.5 and 9. Okay, so it's a fairly unique question, and then there's actually going to be, spoiler alert, 2 tangents, right? There's going to be another one here where it's also going to be tangent to the function like here, and going through the point as well. But let's just keep this one tangent drawn for now, and then you'll see through the algebra how we are going to get 2 solutions. And then at the end, I'll bring back the diagram and show the actual tangents that we do get the equations of them and stuff, and where they lie on this function. So what we have to do here is we need to find out what's this point going to be. We got to find out at what point are we going to have a tangent that's going through this point as well. And so what we can do is this point, let's just label it for now as A, and the y value, because this point is on this function, well, if we have an x value of A, we know that the y value is going to be negative 5a squared minus 1, right? Because the y value is defined in terms of x. So if the x value is a, the corresponding y value is going to be negative 5a squared minus 1, like that. And what we have to do is we actually have to find an expression for the slope of this tangent here in 2 different ways, okay? So we have to find the slope of this tangent in 2 different ways, and the way I like to break these 2 ways down is we're going to do it the grade 9 way, where you first learned about slope of a tangent, and we're also going to do it the grade 12 way, where we know the slope of a tangent is given by the derivative. And what's going to happen is we can create 2 different expressions here for the same slope of this tangent, and then we can make those 2 expressions equal, and those expressions are going to be in terms of a, and then we could solve for a. Okay, so what do I mean by the grade 9 way? So let's maybe bring in a different color here. So the grade 9 way, what I mean is that if you have 2 points, x1, y1, x2, y2, we know that the slope of any line is y2 minus y1 over x2 minus x1, like that. So what I could do is this point here, this general point, I'm going to label, it doesn't matter the order, let's actually just do, yeah, I'll do this as x2, y2, and then I'll do this as x1, y1, like that. So plugging that in here, basically y2, which is this negative 5a squared minus 1 minus the y1, which is the 9, all over x2, which is a, minus x1, which is negative 0.5, right? So just be careful with your signs right there. Okay, so one more time, all I did to get an expression, what I'm trying to do is to get an expression for the slope of this tangent. Well, because we have 2 points on this line, x1, y1, x2, y2, we could just use the slope formula, the general slope formula, y2 minus y1 over x2 minus x1 to get this expression. And so now let's just simplify this expression for now for the slope of the tangent. So notice this negative 1 minus 9, that's going to be negative 10, right? So this is going to be negative 5a squared minus 10, like that. And that's going to be all over a plus 0.5, like that. And then from here, nothing else we can really do to simplify it. So that right there is going to be the expression for the slope of the tangent, one of the expressions for the slope of the tangent that we're going to have. Okay, now the question is, how can we get another expression in this quote-unquote grade 12 way? Well, we know that the slope of the tangent at any x value a of any function is just going to be f prime of a, right? So on any function, plugging in an x value of a into the derivative will give us the slope of the tangent at that specific a value. Well, what we can do, well, we know that this tangent here on this function is happening at this x value of a. So what we can do is we can find the derivative of this function. So what's the derivative of this function going to be? That's just going to be negative 10x. Like that. Quick little intermission here. I wanted to mention a few things and we'll get right back into the video. Number one, if you're watching this on YouTube, you can go to the description box and there's a link that will take you to my website, allthingsmathematics.com, and there you can find all of the videos organized by chapter, by section, and there's also tests that you could try at the end of each unit. Number two, if you feel like you need tutoring at any point, I'm tutoring students 7 days a week over Zoom, both high school and university students, one-on-one and in groups. My contact details are on the website. You could text me and we could book a session. And finally, if you feel like you're getting any value from this video, if you could please like the video and subscribe to the channel, hit me up on all my socials. It does help me out a lot. If you feel like any of your friends can benefit, feel free to forward the website to them as well. And back to the video we go. All right, the derivative of negative 5x squared minus 1 is negative 10x. The derivative of negative 1 is just 0. So if we want the slope of the tangent of this function at this x value of a, well, we just plug in f prime of a into this. That's going to give us negative 10a, like that. And so another expression for the slope of this tangent is negative 10a, like that. So both of these expressions, they basically represent the same slope of the same tangent. All right, so one more time, hopefully you're catching this. You may have to rewind it a bit and listen to it again if you're not catching what I'm saying. It's also tough to explain, right? I'm trying my best here. We got this tangent, this green line, and I found the slope of it with in two different ways. the grade 9 way, y2 minus y1 over x2 minus x1, because we had 2 points. That simplified to this. So this expression is the slope of this green line, and also the grade 12 way, because I know that the slope of the tangent at any x value of a on a function, and this tangent is on this function, the slope of the tangent on the function at that x value of a is just the value of the derivative at that x value of a. So I know that the derivative of this function here, this quadratic, is negative 10x. So at this x value of a, the slope of this tangent here is going to be negative 10a if I plug in that x value of a for x, right? And so this is another expression for the same slope, for the same tangent. Now, if both of these expressions represent the same slope, well, that means that both of these expressions have to equal, right? So this expression has to equal this expression. Okay, this negative 10a, let's like put over 1 because I'm going to end up cross multiplying here, right? Both of these represent the same slope, so we can make both of them equal. And now what we could do is we could solve for the a value that's going to make both of these equal, right? And so to do that, we could just cross multiply. So this times 1 would give us negative 5a squared minus 10 equals, this is negative 10a, this times this, which is a plus 0.5 like that. So this would be what? Negative 5a squared minus 10 is equal to negative 10a squared minus 5a, like that. And then this just ends up being a quadratic. Let's bring everything over to the left side. So this negative 10a squared would turn into a positive. Negative 5 plus 10 would give us positive 5a squared. This turns into positive 5a. And then we got minus 10 like that. And that's going to be 0. And so from here, notice we just have a quadratic equation to solve. And notice here, this is what I was saying before. This is the point in your algebra where you're going to realize there's going to be 2 solutions, right? Now this factors into what? A plus 2, a minus 1. Like that. You could have also put this in the quadratic formula if you want. Sometimes it may not factor smoothly, so you may have to put in the quadratic formula. But this one fortunately did factor smoothly. So we get 2 values, an a value of negative 2 and an a value of positive 1. So now with these 2 a values, let's actually update our diagram that we have here. So first this negative 2, right? So notice that that's going to represent the x value of this point here that we originally drew. So this is going to be negative 2. Now if you remember, this quadratic is represented as negative 5x squared minus 1. So we could actually find the corresponding y value of this point as well. So plugging in negative 2 here, this would be what? 4 negative 20 minus 1, so negative 21 right here. That's going to be this point. Now what about this a value of 1? Well, notice the a value of 1, that's going to be like here. Okay, and so that's where that second tangent is going to come in. And so if I draw that tangent, just roughly, right, not as straight of a line, but hopefully you get what's going on. There's a point over here as well where we're going to have another tangent on this function that's also going through this point, and that's going to happen at an x value of 1, like that. So if we plug in 1 here, we would have negative 5 minus 1, which is negative 6. And this is not to scale, right? Like I know that this point should be a lot lower, right? This y value of negative 21 should probably be like down here, while this point 1, negative 6 would be above. I know it's not to scale. This is just a rough diagram to show you how the 2 tangents are coming about, and just so you have a visual understanding of what's going on versus me just going through the algebra and explaining it like that. I feel like having this this secondary visual helps in further understanding what's going on, right? And so now we got these 2 tangents, and we just basically have to find the equation for them. And so there's different ways to find the equation. I mean, we have 2 points, so we could find the equation the grade 9 way, right? Just doing, what's it called? Y2 minus y1 over x2 minus x1, then solving for the b value, right? This point and this point for this blue line, and then this point and this point for the green line. So you can find the equations of the tangents like that. Let's do it the grade 12 way though. So we know that f of x, the quadratic, is negative 5x squared minus 1. So we know f prime x is negative 10x, right? And so what I could do for each of these points is I could find the slope at those specific x values, right? So if I plug in this x value of negative 2 into the function, negative 10 times negative 2 would give me 20. So this green line here has a slope of 20, and it's also going through this point, negative 2, negative 21. Or you could also use this point to solve for the b value, negative 0.59. It doesn't matter. They should give you the same b value. And then this blue line here, if I plug in 1 into the derivative, right, f prime of 1, that's going to give us negative 10. Okay, and that tangent contains the point 1 and negative 6. Or negative 0.5 and 9 you could use here as well. And notice that the signs of the slopes also correspond with our diagram, right? This green line here has a positive slope, which we got as positive 20. This blue line here has a negative slope, and we got a negative slope there of negative 10. So far it's looking like it's making sense so far. And so at this point we just have to create the equations, right? So let's color coordinate this. So this is going to be the green line. So we'll have y equals 20x plus b. Plug in the point, negative 21, 20 times negative 2 plus b. This is going to be what? Negative 40. Bring it over. Negative 21 plus 40 gives us 19, right? So y is equal to 20x plus 19, like that. That's going to be the equation of this tangent, and then the equation of the blue tangent will have y equals negative 10x plus b. Negative 6 equals negative 10 times 1 plus b. Bring this over. 4 is equal to b, so y would be negative 10x plus 4. Like that, and that would be the equation of this blue line. And then on a test, if you do have time to check, you could try to find the equations for both of these tangents with the grade 9 way, right? Taking this point and this point, doing the y2 minus y1 over x2 minus x1, the slope you get should be 20. Plug that into the line and solve for the b value, right? You should get the same thing, and then with this point and this point, finding the equation the grade 9 way, you should end up getting that same equation of the line. So there's different ways to check your answers as well. They're not foolproof checks, but if you want to be more confident in your solution, there are some opportunities. Okay, so pretty tricky question. Again, I've gone through ones like this in the lecture videos as well, on other tests as well, so make sure you go through those videos too. Maybe pause the video at the beginning, try it yourself, but yeah, potential question that can come up on your test. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.